Alright, hello class. So sorry I'm not in today, just not really feeling the best, but I'll do what I can. So today we're solving equations, or solving equations for view. Alright, and specifically, when it says equations here, we're solving quadratics, alright? So quadratics. Actually, is the whole lesson quadratics? Yeah, whole lesson's quadratics, okay. Yeah, so in this case it's solving quadratics. And I know I've mentioned this a few times in class, but just to recap, the word solving, right? This also just means finding your roots, all right? Finding your zeros. Those all mean the same things, and solving or solution, right? So on a graph, once again, I know I'm going to sound like a broken record, but it needs to be very clear because people always forget what this means in quadratics. It means if you have a quadratic, just some random parabola, you're always finding these points right here. And the reason that those are special is because at those points right there, those are your x-intercepts, and the y values are 0. So if you think about these equations that we've created right here, well, here are your x values, right? And this is usually equal to y. It's giving you your output. Well, in this case, we've set the y to 0. We've set the y here equal to 0. It's already done for us in this problem, but essentially you're saying, well then, the only unknown are these x values. These x, we don't know. We don't know them. And that's what we're solving for. I want to know, what are these x values? What are these x values? So when we solve, all right, this is why we learn how to factor. Factoring is a tool used to solve quadratics. So when looking at this quadratic right here, ask yourself, well, what would this factor into? Well, this is a simple trinomial, so you need two numbers, all right, that multiply to give you negative 22 and add up to give you positive 9. Well, what are the multiples of 22? Well, in this case, it's negative 11, or positive 11, sorry, and minus 2, because positive 11 and minus 2 add up to give you positive 9. Well, it being a simple trinomial, we don't have to do any of that decomposition. So really, your answer is x, or your factors, sorry, are x plus that 11, and then x minus 2. But don't forget, this is equal to 0 now, okay? As opposed to the previous lessons, those were expressions. These are now equations, all right? So we actually have it equal to something. Well, going back, the whole purpose is you're trying to find the x value that would result in this equation being 0. So what number do you substitute in right there for that x? And if you substitute in for that x, it would also need to go here, remember? But what number would you put in there that would give you an output of 0? So essentially you need to think, how do I turn that bracket, that x minus 2 bracket, how do I make that equal to 0? Because 0 times anything, doesn't matter whatever number's in this bracket, will always give you 0, and that's what we're looking for. So solving that first bracket, x minus 2 equals 0, well, we would find that if x equals 2, positive 2, you would get 0. And let's do this one right here. If x plus 11, what would make that bracket equal 0? Well then, if x equals minus 11, if you substitute in minus 11, and again, let's just show what we just found. So we found that when x is minus 11, and if x is equal to 2, okay, so again, how you write that is you would say x equals minus 11 and x equals 2. Those are your two solutions, okay? And let's just prove, okay? So this is just a show. I'm not going to do this for every single one, but let's check. And when I say check, what I'm just saying is like, let's show that those actually result in zeros. So if you have your original expression, all right, you have this x squared plus 9x minus 22, all right? Well, let's see what happens when we plug in one of those values. Just a check, all right? So let's do 2 because it's easier to mental math do it. So if we plug in the 0 that we just calculated, that 2, let's square it plus 9 squared, or sorry, 9 times 2 minus 22. Well, that's going to give us 4 plus 18 minus 22. Well, all of that equals 0. So yes, that's a 0. That results in the y value giving you a 0. And if you do the same for the negative 11, you would also find the same thing, okay? So that is what the goal is. We are finding values that result in the quadratic equaling 0. So this number 2 is just in a different form here, okay? They just rearranged it. But let's put it such that it equals 0 on one side. So we need to bring this 7x over to the other side and this 6 over negative 6 to the other side. So that would give us 2x squared plus 7x plus 6 equaling 0. So again, we are factoring, okay? You're factoring, or if you can't factor, you have to use a quadratic formula, right? But let's see if we can factor this. So this is not a simple trinomial, and we can't factor out, sorry for the cough, we can't factor out the greatest common factor because 7 is not divisible by 2. So we need to use decomposition. 2 times 6 gives us 12. So we need two numbers that multiply to give you positive 12. And those same two numbers need to add up to give you 7. So what are the multiples of 12 that add up to 7? All right, pause if you want to take a second before I give you the answer. But in this case, it's 4 and 3. 4 and 3. So decompose the middle term. All right, so decompose the 7 into 4x plus 3x. Write your other terms plus the 6x. And put your brackets, again, those fake brackets. And this is equaling 0 now because it's not an expression. We're actually solving something. Factor out from the first bracket your GCF. So if I look at 2x squared plus 4x, well there my GCF is 2x, and that would leave me with x plus that 4x being 2. And then out of the second one, I can pull out a 3, positive 3, and then that would leave me with also x plus 2. And again, it's an equation, so it's still equal to 0. You have your common bracket here, and you have everything on the outside. So put those into their factors. So you have your first bracket, which is everything on the outside. And again, it doesn't matter which one you do it as. So there's everything on the outside. And then here's everything on the inside, or the common one, sorry. X plus 2. Okay. So the last one, I went through a lot more elaborate talking, but really, if you think about the math we did in the previous question, all you're doing is you're taking your factors now, you're taking this factor, this bracket, and you're just setting it equal to 0 because you're solving for the value of x that would make that bracket 0, because if this ends up having a value of 0, 0 times, I don't care what this other bracket is equal to, 0 times anything equals 0. So we just need to get, well, all of them, but we need to get the value of x that equals 0. So rearrange this bracket. Rearrange this formula here. So we get 2x, bringing the 3 to the other side, equals minus 3. Or divide both sides by 2. You get x equals minus 3 over 2. So there is one of your solutions, one of your zeros, one of your x-intercepts, all meaning the same thing, okay? X plus 2. So x plus 2 equaling 0, and this one's obviously much easier to do. Just bring that 2 over, and you get your other solution being x equals minus 2. You can always check, plug it back in, and see if it equals 0 when you substitute x equals minus 2 or minus 3 over 2. And I'm trying to put a note here. Leave in exact form, form, okay? No decimals. Only when you go to graph, put that in a decimal. But leave your answer like that. So negative 3/2. Do not put negative 1.5. Okie dokie. Sorry for the coughing. Alright. X minus 1 squared minus 4. Well, again, massive avogadro. I hope that Kahoot helped a lot of you out. But notice here that we have a difference of squares. This is a square, but 4 is also a square. Alright. So the difference of squares formula is a, the square of the first term, plus b, and then a minus b. So the first bracket, all right, the square of our a, the square root of x minus 1 squared is just x minus 1. The square root of 4 is 2. So we will substitute this answer and this answer into our formula here. So we have x minus 1, put that in a bracket. Always good to substitute with a bracket, plus, right, the 2. There's your first one. And we'll clean up our brackets after. And then we have the x minus 1 again. And this time it's now minus 2. So those blue brackets I created there, and again it's equal to 0. Those blue brackets I've created there were unnecessary, so you can get rid of them. And if you collect like terms, you would get x plus 1. And then on the second one, you would get x minus 3. And again, this is equal to 0. So take your two brackets. Here you have x plus 1 equaling 0. And then over here, you have x minus 3 equals 0. Now solve, all right? So in this case, bring the positive 1 over. You're going to get x being negative 1 is a solution. And then bring this minus 3 over. You're going to get x equaling 3 as your second solution. Okay, I hope so far so good. Again, this is a review from grade 10. All right, we're just solving quadratics. You're finding your x-intercepts. So question number 4, always check. Is there a greatest common factor? And in this case, no. There is nothing that we can pull up. So that means we do have to use decomposition to factor this. All right, and again, if you can't use decomposition, then you use quadratic formula. All right, it's kind of like that tier list. That's the route you want to go. You want to avoid using quadratic formula just because it's a lot longer, I know decomp seems like a long time to do it, but with practice you get really quick. So take 3, take 15, multiply them together, get minus 45. So you need two numbers that multiply to give you minus 45, and those same two numbers have to add up to give you minus 4. So pause again if you need to, but try and figure out what your multiples of 45 are that would add up to minus 4. And if you do it, you would find that it would be minus 9 and 5, because minus 9 and 5 multiply and add to the correct numbers. So decompose this term. All right, we're going to get minus 9x plus 5x, and that's going to be 3x squared minus 15 equaling 0. Put your fake brackets, just so we can do our grouping. Pull out of the first bracket a 3x, because that's your GCF there. All right, I'm just going a little faster now because, again, we've been doing this for a bit now, so hopefully this is now getting much easier. All right, and then on the second one, you pull out a plus 5, because that would leave you with x minus 3. You know you've done it correctly if your two brackets are the same, which is what the case is. And then you just write everything on the outside. So the 3x and the plus 5, which are right here and here. That's what goes there. And then you have everything that was the same, the x minus 3. That's right there. All right. And now the next step, because all we've been doing up to this date is factoring, now you're solving. All right, that's why you learn to factor, to solve problems. Factoring is just a tool. So take this bracket, set it equal to 0 so we can now solve. Take this bracket, also set it equal to 0, and solve. So solving the first one that we created, bring the 5 over, right? You're following the rules of SAMDEB, reverse order of operations. So 3x minus 5, and then you divide both sides by 3. So the 3's on this side cancel, and you're left with x minus 5 over 3. And again, leave it in exact form, okay? Do not evaluate that. And then here, it's easy, just bring the 3 over, and you're going to get x is 3. There is your second solution. And just to give you, again, a visual, what you just found here, right? We have a quadratic. In this case, I'm kind of jumping ahead, but I see that the a value here is positive, so I know it's opening up. All right, but you have a quadratic that has a 0 right here at the coordinate 3, 0, the y being 0, and then you have the other one right here. And this is what I mean where you'd actually have to put this into a decimal to know it. So this right here as a decimal, this is negative 1.667. So this is the only time you put it into a decimal, when you actually want to go to graph it. So you put that like right here, for example, and that would be, but I put the coordinates still as a fraction, but I put it in decimal just to find where it is. And that'd be at negative 5/3. And so you found a parabola that has this general shape, okay, with those x-intercepts. These are the solutions. The solutions. I always like to give a big picture, like what you're actually trying to do, okay? So never forget that. Like that's why you're solving quadratics, why we teach factoring and everything. Okay. So let's say, the quadratic formula is given here for a reason, because this is going to be a quadratic formula question. But let's say you didn't know this was a quadratic formula, or if I didn't give it to you on a test. Just go through the checklist. Is there a GCF? No. Okay. Because I can't divide 3 by 2. Or I can't divide 2 by 3. All right. Well, then go through decomp. That's the next method. Take these two numbers, multiply them. You're going to get 6. So you need two numbers that multiply to give you 6. And those same two numbers will have to add up to that middle term. I mean, I'm writing in all green, so let me put a different color. But plus 6. Plus 6. Well, what are the multiples of 6? So 6's are 1 and 6, 2 and 3. But there's no combination that would add up to 6. So none. So this is where decomp fails us. So we have to use quadratic formula, okay? And you have to know this. Must know. Man, I can't even spell no. No. There we go. You must know this formula, all right? I mean, with practice, it becomes engraved to you. It's like knowing your middle name. You just know the quadratic formula. Negative b plus or minus b squared minus 4ac all divided by 2a. All right, so this is in standard form right here, where this right here, there's your a value. This right here, there's your b value. This right here, there's your c value. So take the formula, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And note that this negative b is also being divided by that 2a, okay? So don't forget that. And then plug it in. So all the things that we have. So in this case, b was positive 6. So you have minus 6 plus or minus 6 squared. And then you have minus 4. Our a was 2. And our c was 3. And that is all being divided by 2 times the a value, 2. Okay. X equals, and I just want to highlight something because when I was teaching grade 10, I stressed a lot. This plus or minus right here, that's really important. Having that plus or minus gives you the option to have possibly 2 solutions, because it could be the plus and then as your one solution, and then the minus the square root as your second solution. And having 2 solutions mean that you might have 2 solutions, 2 x-intercepts. All right, so it's that plus and minus there in front of the square root that gives you that ability to. And let's go back. Sorry for the quick tangent there. 6 plus or minus the square root. Okay, so let's clean up the square root there. That's 36, 6 squared, minus 4 times 2 is 8, times that by 3. 8 times 3 is 24. And then that's all being divided by 2 times 2, which is 4. All right, so we get x equals minus 6 plus or minus, well, 36 minus 24 is 12, all over 4. So then you're going to get one solution where you're going to get x equals minus 6 plus the square root of 12 over 4. And then you'll get the second solution, x equals minus 6, and then minus the 12, the root 12, over 4. Okay? So these are exact answers. Well, actually, exact is when you rationalize this. Rationalize. I hope I can spell it properly. Again, I'm a horrible speller. Rationalize. And that just means reduce that square root into the lowest one. So just a quick recap. Again, this is a grade 10 concept. But plus, well, 12 is the same thing as me saying 4 times 3. All right, and 4 I can put as the square root. So over 4. I can take the square root of that 4 and that bring that out. And that would become 2 times root 3, right? Over 4. And then reduce this and this and this term all by a factor of 2. So I would leave that as 1 and 3. And your final answer in exact, most simplified form on this solution would be minus 3 plus root 3 over 2. Okay? So again, that's one solution. And let me box it off, just make it nice and complete. And then over here, you have minus 6, and again, rationalize the 12. So 4 times 3, seeing how that's the multiple. 4 is a square, right? And if you are confused, by the way, on how that actually works, when you have a square, that can be written as the square root of 4 times the square root of 3, right? And taking the square root of 4 gives you the 2 times the root 3. So that is why this becomes x equals, and just like the other one too, minus 2 root 3, right? That's where that 2 is coming from. All over 4. And then reduce, okay? Reduce all terms by a factor of 2. So that becomes a 3, that becomes a 1, that becomes a 2. And you're left with minus 3 minus root 3 over 2. And again, exact answers, okay? Exact answers. How many more do we got here? Last one. All right. So what are we looking at here? How do we do this? Pause for a second, right, if you need to. All right, I know you're probably thinking difference of squares because we have 2 terms here. But the problem is this right here is not a square. There's no 2 here, right? So not a difference of squares. But we also have this 12 over here. So that kind of throws things off too. So this is definitely not a difference of squares problem. So the first thing you need to do, right, after you've done your check is, well, let's get this into standard form, okay? So we need to expand this out first. That's the first step. So expanding this out, that becomes x minus 2, x minus 2, I should rewrite the bracket twice, minus, and then we can put the negative and distribute it in, so that becomes minus 2x, distribute the negative to that negative 1, that becomes plus 1, and let's bring the 12 over to this side of the equation, because again we want it equal to 0. Minus 12 equals 0. Alright, so we did a lot in that first step there. Let's now FOIL out this, so x times that x right there, x squared, and again foiling out something that you should know, so I don't have to go over it. Alright, so that's what you would get. 2x plus 1 minus 12 equals 0. So clean this up. X squared, collect like terms, plus 4 minus 2x plus 1 minus 12. I know I could have cleaned up the constants, but I'm just not wanting to do too many steps in one go. Alright, so now look for your like terms. So here's your squareds. Let's put your x's, your single x's as a red. Here's your reds. And then here are my constants. Okay, so cleaning up the greens, well, there's nothing really to clean up. It's still just x squared. Cleaning up the reds, that becomes minus 6x. And then cleaning up the yellow, that would become 5 minus 12, it's minus 7. And that equals 0. So now factor this. Well, this is nice because this is a simple trinomial. Perfect, so we just need 2 numbers that multiply to give you minus 7. Same 2 numbers add up to give you 6, minus 6. Alright, so in that case, this is 7 and minus 1, 7 and minus 1. And those are 2 factors. So this would be x minus, or plus 7, sorry. And that would be x minus 1 equals 0. Set your 2 brackets equal to 0. So you get x plus 7 equaling 0. And then you get your next one as x minus 1 equaling 0. And that would give you a solution of x minus 7. That's your first one. And then your next one would be 1. And there you go. Okay. If you have any questions, please feel free to reach out to me. Hope that none of that was brand new information. I know the hardest thing probably was maybe this, where I talked about rationalizing. Again, if you need help, just reach out to me, okay? All right. Hopefully I'll see you in class on Tuesday. Bye now.